Welcome to screencast session on week 4 pre and post numbering using depth first search. So this is one of the interesting application of depth first search. So when we are implementing depth first search in this coding session, we don't want to use that explicit stack. So we use a recursive approach of the depth first search so that backtracking can be done. So let's do that. Some global variables. So we are having the three global variables, that is widgeted, pre-numbering and post-numbering. All these three belongs to that empty dictionaries. So that whenever you declare a global variable, you can reduce the number of parameters in the function. So let's implement that initialization function. So we want to do the initialization using a user-defined function. So DFS init, pre and post. So it is exclusive for initializing that values for the the global variables already you have declared. It takes that adjacency list as a parameter. For each vertex we are getting from the adjacency list. So that is called keys. The each key we are getting. So we want to initialize that widgeted. So as you know, the widgeted is always we are putting it. Initially it is false. So then after it, the pre and post. So the pre dictionary. So each vertex and the post dictionary, the post value maintaining the dictionary. So it is each vertex. We want to set it that pre and post values. Initially it's going to be -1 and -1. So why it is -1 is, so initially we don't know the tracking of that each one. So that basically root also it is -1. So later when it starts the depth first search, the root will become the pre-numbering as 0 because -1 will be incremented to 0. So now, so let's go for that the major function implementation, that is so DFS pre and post. So this one is having some initial setup of values. So that is we are setting that widgeted values of that. So this initialization can be done at, so using predefined function. Let me do that. We want to start it from, so widgeted of the starting vertex which you have been chosen, where you want to start the depth first search, that initially we are putting it is 0, sorry, it's a true. So then after it, so we want to assign the value for the pre-widgeted as and when the root has been widgeted. So it will become that the count of that which count you have been passed. Initially the count we pass it as a 0. So then we are incrementing the count because once it has been widgeted, simply we want to increase it. So count equal to, so that's we are increasing count plus equal to 1. So that the first root has been considered as a root and as well as that it is increased. So then we want to iterate, so over that each vertex of the V. So that is for adjacent, whatever adjacent vertices are there, the each adjacent vertex in that adjacent list of the V is going to be that the root which you consider the first time. Second time it's different. If that is not widgeted, so when that is not widgeted, so we want to make it widget by calling the same function again, that is DFS pre and post. We are sending the same adjacency list. As I said, it's a recursive approach we are applying. So adjacency vertex and as well as the existing count is being passed. So then after it, after all that, we are going to leave that post. So when you are trying to leave the particular vertex, we want to assign the post number, maybe like when you are coming out of this for loop. So simply the post count is increased, assigned with count, and count is increased by +1. So when it is backtracking is happening, no more of widgeting every time. So that count will be increased to +1. So finally we want to return the final result. The final result of pre and post we want to return. So maybe it's a final result is not pre and post, simply the count which is used recursively. So return the count value because it's a recursive call, we want to do that. So then after it, so we will use it from a main code, the main function, because basically you not return the pre and post. Pre and post is anyway it's declared at the top as a global variable. Simply we can print them so inside of your main. So in this I want to create adjacency list of graph. So So that is, adjacency list we are using. The 0th vertex, it's having the adjacents of 1 and 4. So randomly I'm creating. The first vertex is having that adjacent of 0, and second vertex is not having any adjacents. So third vertex intentionally I'm giving no particular adjacents, but the fourth vertex we are giving that adjacents of 0, 8 and 9. So then after it, fifth vertex I don't want to give any adjacents. Sixth vertex I want to make it, it's a no adjacents, and seventh vertex also I don't want to give any adjacents, but eighth vertex is having two adjacents of 4 and 9 vertices, and ninth vertex it is having that, so 8 and 4, something like this. So what exactly, why do you put this particular one is empty? These things are disconnected components in the graph. Once they are the disconnected components, there is no chance of pre and post numbering for this, but whatever adjacents are there, definitely DFS is executed. When that is executed DFS, definitely you get it, pre and post numbering for this. So once that is done, then let's do that initialization part. So we are calling that initialization function is, that is DFS init. So it's taking the adjacency list as a parameter, so that pre and post and widgeted things have been initialized. Now let's call that. So the printing of that DFS pre and post, it takes the three parameters, the adjacency list as a parameter, and 0th vertex we start it as a root, and 0 is my initial count because initially we don't have any count. So once that is executed, so let's print widgeted one, that is the current status of the widgeted, and what is the pre-numbering, printing of the pre-numbering, the dictionary of pre, and printing of the post. So hope you have understood everything. Let's run this. So we are widgeting that 0 and 1, but 2 is not widgeted because it is not adjacent to any of the previous 0 and 1. 3 is not widgeted, but 4 is widgeted. So because 4 is adjacent to the 0, 5 is not widgeted because it's not adjacent to anybody, 6 is not widgeted, 7 is not widgeted, but 8 is widgeted, and 9 also is widgeted. So now let's go for that, the particular pre-numbering. If you could see the pre-numbering of it, so we have been widgeted to the 0 because it's going to the first node. So then after it 1, so because it is forward traversing or forward widgeting. So when it comes to the 4, because it is a, going for that 4, we want to do the backtrack of that, that is going to be 3. So then it is 8. So after getting to the 8 is a fourth kind, pre-numbering has been done. 9 is going to be the pre-numbering of 5. And once all this is done, so that once the backtracking is executed, so after that 9 times no more widgeting of that 0, so that's called post numbering. That's the last exit point of the 0th vertex. Similar lines, so vertex 1 is the post numbering is 2, and if you could see that vertex number 4, it's a post numbering is 8. So and similar lines, if you could see that 8th vertex, the post numbering is 7, and vertex 9 is the post numbering is 6. So hope you got it. The remaining vertices are -1 because they are not connected components of the graph. So thank you very much. Have a nice day.